Module 6, Changes in Matter in Chemical Reactions. Determining whether or not a chemical equation is balanced. Balancing chemical equations really just involves keeping track of all the atoms on each side of the arrow. We need to make sure that the number of each type of atom on the reactant side is the same as the number of that type of atom on the product side. It's like a seesaw. We have to have an even amount or it won't be balanced. So if you have a chemical equation with 5 carbon atoms on the reactant side, then you need to make sure you have 5 carbon atoms on the product side. And there's an easy way to make sure you are able to do this. Look at the burning of methane balanced equation again. Notice the oxygen molecule on the reactant side. It has a subscript telling you that the individual molecule of oxygen contains 2 oxygen atoms, but the coefficient tells us there are 2 oxygen molecules. If each oxygen molecule has 2 oxygen atoms, and there are 2 oxygen molecules, how many individual oxygen atoms are we looking at? 2 times 2, or 4. And you can see that indeed there are 4 oxygen atoms here. 1, 2, 3, 4. So to count the number of atoms on each side of the equation, we need to multiply the number to the left of the molecule, or the coefficient, by the subscript number that follows each atom. So how many carbon atoms are there? 1 molecule of methane times 1 carbon atom. The subscript is an understood 1, and we get 1 carbon atom on the reactant side. Now let's do the same thing for the product side. 1 carbon dioxide molecule with 1 carbon atom in the molecule results in 1 times 1, or 1 carbon atom on the product side. We have a single carbon on both sides of the equation, so we can say that the equation is balanced with respect to carbon. Now we can count the hydrogen atoms on both sides. 1 molecule of methane times 4 atoms of hydrogens in that methane equals 4 hydrogen atoms on the reactant side. For the products, we have 2 molecules of water times 2 hydrogen atoms in that single molecule of water equals 4 hydrogen atoms. We have 4 hydrogens on both sides of the equation, so we can say that the equation is balanced with respect to hydrogen. Lastly, we can count the oxygen atoms on both sides. Beginning with the reactants, we have 2 molecules of oxygen times 2 oxygen atoms per molecule to get 4 total oxygen atoms. On the product side, we have oxygen in both molecules. There is 1 molecule of carbon dioxide times 2 oxygen atoms in that molecule. And there are 2 molecules of water times 1 oxygen atom in each molecule. Adding them up, we have a total of 4 oxygen atoms. We can say that the equation is balanced with respect to oxygen too. So because this equation is balanced with respect to all the atoms, it is completely balanced. Look at another example with me. Determine whether or not the following equation is balanced. 2 hydrogen chloride aqueous plus calcium bromide solid produces 2 hydrogen bromide aqueous plus 2 calcium chloride solid. To figure out if this is a balanced equation, all we need to do is count up the numbers of the atoms on each side of the equation and see if they match up. Let's look at hydrogen first. There are 2 HCl molecules times 1 hydrogen atom in each molecule for a total of 2 hydrogens on the reactant side. There are 2 HBr molecules times 1 hydrogen atom in each molecule for a total of 2 hydrogens on the product side. The equation is balanced with respect to hydrogen. Now chlorine. There are 2 HCl molecules times 1 chlorine atom in each molecule for a total of 2 chlorines on the reactant side. There are 2 CaCl2 molecules times 2 chlorine atoms in each molecule for a total of 4 chlorines on the product side. There are more chlorine atoms on the product side than the reactant side, so the equation is not balanced with respect to chlorine. So we can say the whole equation is not completely balanced. We have our answer. But just to continue the practice of doing this, let's continue. For calcium, there is 1 CaBr2 molecule times 1 calcium atom in each molecule for a total of 1 calcium atom on the reactant side. There are 2 CaCl2 molecules times 1 calcium atom in each molecule for a total of 2 calcium atoms on the product side. This equation is not balanced with respect to calcium either. Finally, bromine. There is 1 molecule of CaBr2 times 2 bromine atoms in each molecule for a total of 2 bromine atoms on the reactant side. There are 2 HBr molecules times 1 bromine atom in each molecule for a total of 2 bromines on the product side. The equation is balanced with respect to bromine. but because at least one type of atom is not balanced, we have to say that the entire chemical equation is not balanced. Okay, one more. Determine whether or not the following equation is balanced. 6CO2 plus 6H2O produces C6H12O6 plus 6O2. This equation in words is 6 carbon dioxide molecules plus 6 water molecules produces 1 glucose molecule plus 6 oxygen molecules. All we do is count the atoms on both sides of the equation to see if they balance. Beginning with carbon, we have 6 molecules of CO2 times 1 carbon atom in each molecule for a total of 6 carbon atoms on the reactant side. There is 1 molecule of C6H12O6 times 6 carbon atoms in each molecule for a total of 6 carbon atoms on the product side. The reaction is balanced with respect to carbon. Now oxygen. It is in both reactant molecules, so we have 6 molecules of CO2 times 2 oxygen atoms in each molecule, plus we have 6 molecules of H2O times 1 oxygen atom in each molecule for a total of 18 oxygen atoms. Now for the product side. Oxygen is in both products, so we have 1 molecule of glucose times 6 oxygen atoms in each molecule, plus we have 6 molecules of O2 times 2 oxygen atoms in each molecule for a total of 18 oxygen atoms. So we can say the reaction is balanced with respect to oxygen. Finally, hydrogen. We have 6 molecules of H2O times 2 hydrogen atoms in each molecule for a total of 12 hydrogen atoms on the reactant side. We have 1 molecule of glucose times 12 hydrogen atoms in each molecule for a total of 12 hydrogen atoms on the product side. The equation is balanced with respect to hydrogen. Because all the atoms are balanced, we can say that this is a balanced chemical equation.